In this video, we will be discussing production theory for two inputs and how we can find the maximum quantity produced with these two inputs. We have a problem that introduces K as capital, where we have Q equals 20K to the 1/3 power times L to the 2/3 power, and we're given a price of K, a price of capital, equals 30, a price of labor equals 60, and M, which is our budget, equals 500,000. And we're asked to find the marginal productions of labor and capital, as well as find the production maximizing labor and capital, and find the maximum quantity we can produce. So first up, let's find our marginal productions. So we'll find the marginal production of labor first, which is the derivative of Q with respect to L. And so we treat K like it's another number, so we have 20K to the 1/3. And since L is the variable in this case, we take its derivative, so we have 2/3 times L to the negative 1/3, because 2/3 minus 1 is negative 1/3. And if we were to simplify things, we would be left with 40K to the 1/3 over 3L to the 1/3, because the negative tells us to move it to the bottom. Next up, we can find our marginal production of capital, which we denote by K, which is the derivative of the quantity function with respect to K. And so we do the same process. So we have the 20L to the 2/3, so we leave this alone because it's our coefficient, and then we take the derivative of K, which is 1/3 K to the negative 2/3. And if we were to simplify this, MPK equals 20L to the 2/3 over 3K to the 2/3. And we have found our marginal productions of labor and capital. So in order to find our production maximizing labor and capital, we need to use a relationship stated by our marginal rate of technical substitution, which states the marginal production of labor over the marginal production of capital is equal to the price of labor over the price of capital. And so what we can do is we can start plugging things in. So our marginal production of labor is 40K to the 1/3 over 3L to the 1/3 over 60, and that is equal to 20L to the 2/3 over 3K to the 2/3 over 30. And if we were to simplify things, so by multiplying the reciprocal of the fractions, so 40K to the 1/3 over 3L to the 1/3 would be multiplied by 1 over 60, and that's also equal to 20L to the 2/3 over 3K to the 2/3 would be multiplied by 1 over 30. And so if we simplify a bit further, we're left with 2K to the 1/3 over 9L to the 1/3 equals 2L to the 2/3 over 9K to the 2/3. And now what we can do is we can cross multiply And by cross multiplying, we're given 18k, because 1/3 plus 2/3 is 1 after we multiply the two, k and k, and that equals 18L. And if we divide both sides by 18, we are left with k equals L as our input ratio. Using this input ratio and knowing our budget and the prices, we can use the function of M, so our budget equals the price of L times L plus the price of capital times K, and we can use our input ratio to find what L and K are. So our budget was 500,000. The price of L was 60 times L plus the price of K, which was 30 times K. And if we were to plug L in for K, we would be left with 500,000 equals 60L plus 30L. And by combining like terms, we still have the 50,000, and that equals 90L. And if we divide both sides by 90, we are left with L equals 5555.56, or 5,555.56. And due to our input ratio being L equals K, we also know that K equals 5,555.56. Our last step is to find our maximum quantity. So what we would do is we would plug L and K into our original Q function. So Q equals 20 times 5,555.56 to the 1/3 times 5,555.56 to the 2/3. And after plugging that into a calculator, we're left with Q equals 111,111.11. And that is our maximum quantity we can produce with our production maximizing levels of labor and capital. That will conclude this video on two-input production and finding the maximum quantity we can produce given these two inputs. Please watch part 3, where we will be discussing finding the maximum budget we are allotted given a quantity and these two inputs.